Now let's look a little bit beyond expected value and standard error and talk about confidence intervals.
So now we can say how confident we are in a range.
Exactly. So we're going to use the expected value and standard error to create these things called confidence intervals. And I'm going to use our same example that we discussed in a previous video, and I have it right here. It says in February of 2019, a CNN poll of 1,011 adults nationwide asked the following question: do you think the government should provide a national health insurance program for all Americans, even if this would require higher taxes? And we got 54% of people saying yes, and this was a simple random sample. So we got a sample percentage of 54%. That was our expected value. And we had calculated the standard error to be, wait, do you remember what it was?
Yeah, I still have it up. It's 1.566%.
So I'm going to say 1.57%.
Sounds great.
So that was our standard error. So I could go ahead and say that 54, give or take about 1.57% of people would say yes to this question in our population. But a lot of times as statisticians and data scientists, we're asked, well, how confident are you that that is right? So how sure are we that if we really polled all US adults, we'd get 54, give or take 1.57%, saying that they favor a national health insurance program. And the nice thing here is that we can actually use the normal curve to answer that question, because we know the probability histogram for the sample percent follows the normal curve because of the central limit theorem. This also works for sample averages, for sums, etc. So A says, suppose we wanted to be 80% sure that the true population percent lies in our confidence interval. It asks how many standard errors do we need to attach to 54% favoring a national health insurance program. So in other words, this is asking for an 80% confidence interval. If we're 80% sure that the true population percent lies in our range, we're going to do an 80% confidence interval. So basically all I want to do is take my sample percent, this 54, and I'm going to add and subtract a certain amount of standard errors. The question is how many, and it relates to the normal curve. So basically we want to figure out what are these z-scores where the middle area on the curve is 80%, because then we're saying, okay, that's 80%, we're 80% sure that the true population percent lies within our interval. So wait, we've been working a lot with CDFs and PPFs and Python, figuring out areas with the normal curve. If I want to know what the z-score is for 80% in the middle, how would you go about solving that question?
Yeah, so I see this as like the best application of the probability point function of saying, where do we get to the point where so much of the data is to the left of it? And I know the normal curve is symmetric.
Yes.
So I would say if 80% is in the middle, I know both tails have 10% in them each.
Exactly.
So I can ask Python either to know what that first line is at the 10% mark or at the 90% mark. Do you want the negative or the positive value?
Ooh, so I'm gonna, in my formula for the confidence interval, it's plus or minus, so it doesn't actually matter. So I think to me the 10%, the negative one makes a little bit more sense, but we could do the 90th percentile as well.
So let's go ahead with that 10 percentile.
Okay.
So that's a probability point function where we want to know what is the z-score when we have 10% of the data to our left.
Exactly.
So I'm going to type norm.ppf after importing the norm library. And norm.ppf 0.1 tells us that the z-score is at negative 1.28.
1.28. And then let's just do, just to confirm, let's do the PPF for 0.9. So right at this line, there's 80% plus 10% to the left of my z-score, and this should just be positive 1.28. So,
and I did norm.ppf of 0.9, and it is exactly the same number all the way out to the 15th decimal point.
Wow. So 1.28 and then all the way up to the 15th decimal point. So that's the z-score that I'm going to plug in right here, 1.28. And the minus is taken care of because it is plus or minus. So in general, for a confidence interval, I can have a whatever percent confidence interval. And that's just going to be my sample percent plus or minus my z-score times my standard error. And the z-score actually comes from This is determined by how confident we are. Comes from the confidence level is what we like to call that. So I guess I'll go ahead and figure out what an 80% confidence interval is, just so we can see what that ends up being. So I have 54% plus or minus 1.28, and then the standard error was 1.57%. So Wade, if you could give me both of those endpoints, we will figure out what the confidence interval is.
Wow, so if I do 1.28 times 1.57, I get 2.009. So basically almost exactly 2%.
Let's round to 2. So I have 54 minus 2, which is 52%, to 54 plus 2, which is 56%. And so this means, if I wanted to write this in words, this basically means that I am 80% sure that if I polled all US adults and asked them this question, the true percent would be between 52 and 56%. And one last thing for the confidence interval that I want to mention is that this part of the confidence interval, the part on the right of the plus or minus, the z-score times the standard error, is often referred to as the margin of error. Because it's saying, what do we add and subtract from our sample percent to get our confidence interval? So down here, it says, find the following confidence intervals for the percent of all US adults who favor a national health insurance program. And we have a 68% confidence interval, a 90% confidence interval, and a 95% confidence interval. So for the 68% confidence interval, I know I'm going to take the 54 plus or minus a z-score times my standard error. So actually for all of these, I'm just going to go ahead and add 1.57 because the standard error always stays the same. So we have our expected value plus or minus my z-score times my standard error. So for a 68% confidence interval, I can do kind of the same thing to find the z-score. Basically, let's see, I'm running out of room here. I'll draw my normal curve right here. I want the middle area to be equal to 68%. So I like just looking at the negative z-score. So if there's 68% in the middle, that means there is 32%
yep.
in both of the tails. So there's 16% on either tail. So Wade can go ahead and type in norm.ppf of 0.16 to get our z-score.
So norm of 0.16 gives us negative 0.994.
So I'm just going to go ahead and round that to 1. So I'm going to say my z-score for a 68% confidence interval is 1, and that's one that's really common that you'll see a lot. Same with 95%. If we actually did the z-score for that, it ends up being 2. Those are very common z-scores for confidence intervals. So I can go ahead and figure out this range. So for the 68% confidence interval, I have 54 minus 1 times 1.57.
So 1 times 1.57, I just typed that in, which is 1.157. So 54 minus 1.57 is 52.43.
52.43, and then 54 plus 1.57 is just 55.57. And let's go ahead and do it for 2 as well. So for 2, I get 54 minus 2 times 1.57.
Which is 50.86.
50.86.
And then 54 plus 2 times 1.57 for the upper range is 57.14.
57.14. And I encourage you to try the 90% confidence interval on your own. It's the exact same procedure as the other two. And we can see just from going from the 68 to the 80 to the 95% confidence interval that actually as we get more confident, the more confident we get, the wider our interval becomes. So the 68% confidence interval is the narrowest and the 95% confidence interval is the widest. So the more confident we are, the wider our interval. And then just to kind of sum up confidence intervals for percents, the very last question says, which of the following statements is true? And they all look very similar. They're saying our 95% confidence interval can be applied to, we have all adults worldwide, all adults nationwide, and all US females. So Wade, which one do you think it is?
So I don't actually know. I'd have to go back to the survey and see what the population of the survey was.
Exactly, because remember, our sample is only representative of the population it was drawn from. And if I look back up here, it was adults nationwide. So do any of these mean the same thing as adults nationwide?
Looks like that middle option.
Looks like number 2. And then down here, we just have that rule. Again, the sample doesn't represent any subgroups of the population or wider groups, just that population of adults nationwide. And that is a quick introduction to confidence intervals for percents. We're also going to dive into confidence intervals for means next in this series.
Can't wait for those means.